Have you ever looked at a FAANG SQL interview question and thought, there's no way I'll ever understand this? What if I told you that every advanced SQL query, from window functions and CTEs to complex joins and subqueries, is built from just a handful of basic SQL concepts? In this series, we are doing something different. We are not learning SQL from basic to advanced. We are reverse engineering SQL. We'll start with real FAANG-level interview questions, break them apart line by line, uncover the hidden logic behind every clause, and rebuild them into simple SQL that anyone can understand. No memorization. No confusing jargon. Just clear thinking, real business examples, interview insights, visual explanations, and coding practice that helps you think like a professional data analyst. By the end of this series, you won't just know SQL syntax, you'll understand why every query works and how to solve real-world business problems with confidence. If your goal is to crack data analyst interviews, build powerful SQL skills, or become job-ready faster than 99% of learners, you are in the right place. Subscribe now, turn on notifications, and let's decode FAANG SQL together, one query at a time. Beyond FAANG SQL Basic SQL. Chapter 1, Window Functions, Reverse Engineering. Master window functions by breaking them down to basic SQL. First principles. Imagine you are a teacher with a class of students. Student. Marks. Ali.
95.
Sarah.
88.
John.
95.
Aisha.
82.
David.
75.
The principal asks, who came first? Who came second? What is each student's rank? What is the running total of marks? Who scored more than the previous student? These questions require comparing one row with another while keeping every student's row visible. That's exactly why window functions exist. Why were window functions invented? Before window functions, SQL could calculate totals using group by. Example. Select department. Average salary. From employees. Group by department. Output. Department. Average salary. IT.
65,000.
HR.
52,000.
But notice something. Where did the employees go? They disappeared. Sometimes businesses need both. Individual employee details. Department average. Window functions solve this. Mental model. Think of a train. Each coach is one row. A window function looks through the train window and performs calculations across nearby coaches without removing any coach. General syntax. Function over. Partition by column. Order by column. Think of it like this. Function. Over. Partition. Order. Reverse engineering. FAANG query. Select employee_name. Salary. Rank over. Partition by department. Order by salary DSC. Rank no. From employees. Looks difficult. Let's remove one layer at a time. Remove partition. Select employee underscore name. Salary. Rank over. Order by salary DSC. From employees. Now everyone is ranked together. Remove rank. Select asterisk. From employees. Order by salary DSC. Now SQL is simply sorting. Remove order by. Select asterisk. From employees. The advanced query became the most basic query. Example 1 row underscore number. Business question. Assign every employee a unique number based on salary. Table. Name. Salary. Ali.
50,000.
Sarah.
60,000.
John.
70,000.
Aisha.
$80,000.
Query. Select. Name. Salary. Row underscore number over. Order by salary DSC. As row underscore no. From employees. Output. Name. Salary. Row underscore no. Aisha.
80,000. 1.
John.
70,000. 2.
Sarah.
60,000. 3.
Ali.
50,000. 4.
Underline logic. Step 1. Sort salaries.
80,000. 70,000. 60,000. 50,000.
Step 2. Assign numbers.
1. 2. 3. 4.
Nothing magical happened. Example 2 rank. Table. Name. Salary. Ali.
70,000.
Sarah.
70,000.
John.
60,000.
David.
50,000.
Query. Select. Name. Salary. Rank over. Order by salary DSC. As salary underscore rank. From employees. Output. Name. Salary. Rank. Ali.
70,000. 1.
Sarah.
70,000. 1.
John.
60,000. 3.
David.
50,000. 4.
Notice rank 2 is skipped. Why? Two people shared rank 1. Example 3 dense underscore rank. Select. Name. Salary. Dense underscore rank over. Order by salary DSC. Dense underscore rank. From employees. Output. Name. Salary. Dense rank. Ali.
70,000. 1.
Sarah,
70,000. 1.
John,
60,000. 2.
David,
50,000. 3.
difference, rank,
1. 1. 3. 4.
dense underscore rank,
1. 1. 2. 3.
memory trick. Rank is equal to leaves gaps after ties. Dense underscore rank is equal to dense means no empty spaces. Example 4 running total. Table. Month. Sales. Jan.
100.
Feb.
150.
Mar.
200.
April.
300.
Query. Select. Month. Sales. Sum sales. Over. Order by month. Running underscore total. From sales. Output. Month. Sales. Running total. Jan.
100. 100.
Feb.
150. 250.
Mar.
200. 450.
April.
300. 750.
Underline logic. Jan.
100.
Jan plus Feb.
250.
Jan plus Feb plus Mar.
450.
Jan plus Feb plus Mar plus April.
750.
Example 5 Department ranking. Table. Department. Employee. Salary. IT. Ali.
70,000.
IT. Sarah.
90,000.
HR. John.
50,000.
HR. David.
60,000.
Query. Select. Department. Employee. Salary. Rank over. Partition by department. Order by salary DSC. Department underscore rank. From employees. Output. IT. Employee. Rank. Sarah.
1.
Ali.
2.
HR. Employee. Rank. David.
1.
John.
2.
Underline logic. Partition by creates separate ranking groups for each department before applying rank. FAANG interview questions. What is the difference between row underscore number, rank, and dense underscore rank? What does over do? Why use partition by? How do you find the top 3 salaries in each department? When would you choose a window function instead of group by? Common mistakes. Cross mark forgetting order by inside over. Cross mark confusing rank with dense underscore rank. Cross mark using group by when you need to keep all rows. Cross mark forgetting that partition by restarts the calculation for each group. Practice exercises. Assign row numbers based on employee age. Rank products by price. Calculate a running total of monthly revenue. Find the highest paid employee in each department. Show the top 2 customers by total spending in each region. One-page revision sheet. Function. Purpose. Row underscore number. Unique sequential number. Rank. Ranking with gaps after ties. Dense underscore rank. Ranking without gaps. Sum over. Running total. Partition by. Split data into groups. Order by. Define calculation order. Over. Specify the window for the calculation. 80/20th rule. If you master these 6 concepts. Over. Partition by. Order by. Row underscore number. Rank. Dense underscore rank. You'll be able to solve a large share of window function questions asked in data analyst interviews, including many seen at top tech companies. When you are ready, reply to for Chapter 2 CTEs, Common Table Expressions, where we'll reverse engineer temporary tables back to the simplest select queries with another set of 5 fully explained examples. Beyond FAANG SQL Basic SQL. Chapter 2 CTE, Common Table Expression. Reverse engineering FAANG SQL into Basic SQL. First principles. Imagine you are solving a math problem. Instead of writing everything in one giant equation, you solve it step by step. Example. Step 1.
10 plus 20 is equal to 30.
Step 2.
30 times 5 is equal to 150.
The answer is easier to understand. ACTE, Common Table Expression, does the same thing for SQL. Instead of writing one huge query, you break it into smaller, readable steps. Why was CTE invented? Imagine a company has 10 million sales records. Your manager asks, find the top 5 customers who spent the most money this year. Without a CTE, the SQL can become long and difficult to read. With a CTE, you first calculate each customer's total sales, then use that result in the final query. Think of it as solving a problem on rough paper before writing the final answer. Mental model. Raw data. CTE, temporary result. Final query. A CTE exists only while the query is running. It is not saved permanently in the database. Basic syntax. With CTE underscore name as select. Select asterisk. From CTE underscore name. Breakdown. With start a temporary table. CTE underscore name give it a name. As define what's inside it. Select use it like a normal table. Reverse engineering. FAANG query. With employee sales as select. Employee underscore ID. Sum sales as total underscore sales. From orders. Group by employee underscore ID. Select asterisk. From employee sales. Looks advanced. Let's remove one layer at a time. Step 1. Inside the CTE. Select. Employee underscore ID. Sum sales. From orders. Group by employee underscore ID. This simply calculates total sales. Step 2. The outside query. Select asterisk. From employee sales. This just reads the temporary table. Step 3. Remove the CTE. Select employee underscore ID. Sum sales. From orders. Group by employee underscore ID. C. The CTE was only making the query easier to read. Example 1. Simple CTE. Table employees. ID. Name. Salary.
1.
Ali.
50,000. 2.
Sara.
70,000. 3.
John.
60,000.
Query. With employee data as. Select name. Salary. From employees. Select asterisk. From employee data. Output. Name. Salary. Ali.
50,000.
Sara.
70,000.
John.
60,000.
Underline logic. Read employees. Create temporary table. Read temporary table. Example 2. Filter using ACT. With high salary as. Select from employees. Where salary 60,000. Select asterisk. From high salary. Output. Name. Salary. Sara.
70,000.
Underline logic. Filter. Save result temporarily. Display result. Without a CTE, you could simply write. Select asterisk. From employees. Where salary 60,000. The CTE improves readability when queries become more complex. Example 3. Aggregate using ACT. Table orders. Customer. Amount. Ali.
100.
Ali.
300.
Sara.
500.
Sara.
100.
Query. With customer sales as. Select customer. Sum amount as total underscore sales. From orders. Group by customer. Select asterisk. From customer sales. Output. Customer. Total sales. Ali.
400.
Sara.
600.
Underline logic. Orders. Group by customer. Add amounts. Temporary table. Display. Example 4. Top customer. With customer sales as. Select customer. Sum amount as total underscore sales. From orders. Group by customer. Select asterisk. From customer sales. Order by total underscore sales DSC. Limit 1. Output. Customer. Total sales. Sara.
600.
Underline logic. Calculate total sales. Sort. Take first row. Example 5. Multiple CTEs, FAANG style. With customer sales as. Select. Customer. Sum, amount, as total underscore sales. From orders. Group by customer. Top customers as. Select asterisk. From customer sales. Where total underscore sales 500. Select asterisk. From top customers. Output. Customer. Total sales. Sarah.
600.
Underline logic. Orders. CTE 1. Calculate sales. CTE 2. Filter customers. Final result. This is a common pattern in real-world analytics. Each CT performs one clear task. Real-world business use cases. Monthly sales reports. Customer lifetime value. Employee performance dashboards. Financial reporting. Data cleaning pipelines. Breaking large analytical queries into manageable steps. Beginner versus expert. Beginner writes one long query that's hard to read. Intermediate uses a CTE to organize logic. Advanced chains multiple CTEs to solve complex problems. Expert designs modular, readable, and maintainable SQL while considering performance and alternatives. Common mistakes. Crossmark giving unclear CTE names. With temp 1 as. Better. With customer sales as. Crossmark creating unnecessary CTEs for very simple queries. Crossmark assuming a CTE is permanently stored in the database. A CTE exists only during the execution of that query. FAANG interview questions. Q1. What is a CTE? Answer. A temporary named result set that exists only during the execution of a SQL statement. Q2. Why use a CTE instead of a subquery? Better readability. Easier maintenance. Reuse within the same query. Breaks complex logic into steps. Q3. Is a CTE stored permanently? No. Q4. Can multiple CTEs be used? Yes. They can build on each other in a sequence. Q5. Can a CTE improve performance? Not necessarily. It mainly improves readability. Depending on the database engine and query optimizer, performance may be similar to or different from an equivalent subquery. Practice exercises. Create a CTE that lists all employees from the IT department. Create a CTE that calculates each customer's total purchases. Use a CTE to find the highest paid employee. Create two CTEs, one for monthly sales and another to filter months with sales above 1 lakh rupees. Rewrite a nested subquery using a CTE. One-page revision sheet. Concept. Meaning. With. Start a temporary named result. As. Define the query for the CTE. CTE. Temporary table for the current query. Multiple CTEs. Build logic step by step. Scope. Exists only during query execution. Memory trick. With is equal to work in temporary helper. Think. Problem. CTE. Final query. Answer. 80/20th rule. Most interview questions involving CTEs rely on just these patterns. Filter data. Aggregate data. Join intermediate results. Chain multiple transformations. Improve readability of complex SQL. Master these 5 patterns, and you will be well prepared for many real-world and interview scenarios. Reply 3 when you are ready for Chapter 3, Case When, where we'll reverse engineer conditional logic from FAANG-style queries down to simple if-else thinking with 5 fully explained examples. Beyond FAANG SQL Basic SQL. Chapter 3, Case When, FAANG Basic SQL. First principle, case when is nothing more than if-else in SQL. Why was case invented? Imagine you are an HR manager. You have this employee table. Employee. Salary. Ali.
40,000.
Sarah.
65,000.
John.
90,000.
David.
30,000.
Aisha.
75,000.
Your manager asks. Show high salary if salary 70,000. Show medium salary if salary is between 50,000 and 70,000. Otherwise show low salary. SQL needs a way to make decisions. That's why case when exists. Mental model. Think like a traffic signal. Condition. True. Yes, result A. No. Next condition. Yes, result B. No. Else. Basic syntax. Case. When condition 1 then result 1. When condition 2 then result 2. Else result 3. End. Think of it as if, else if, else. Reverse engineering. FAANG query. Select. Employee underscore name. Salary. Case. When salary is equal to 100,000 then director. When salary is equal to 70,000 then senior. When salary is equal to 50,000 then mid. Else junior. End as employee underscore level. From employees. Looks advanced. Let's simplify it. Step 1. Ignore SQL. Read it like English. If salary is equal to 100,000. Director. Else if salary is equal to 70,000. Senior. Else if salary is equal to 50,000. Mid. Else. Junior. Step 2. Now write it in SQL. Nothing changed except the syntax. Example 1. Pass or fail. Table. Student. Marks. Ali.
90.
Sarah.
30.
John.
75.
David.
40.
Query. Select. Student underscore name. Marks. Case. When marks is equal to 35 then pass. Else fail. And as result. From students. Output. Student. Marks. Result. Ali.
90.
Pass. Sara.
30.
Fail. John.
75.
Pass. David.
40.
Pass. Underline logic. Marks is equal to 35. Yes. Pass. No. Fail. Example 2. Salary category. Select. Employee underscore name. Salary. Case. When salary is equal to 70,000 then high. When salary is equal to 50,000 then medium. Else low. And salary underscore level. From employees. Output. Name. Salary. Level. Ali.
40,000.
Low. Sara.
65,000.
Medium. John.
90,000.
High. Underline logic. Salary is equal to 70,000. High. No. Salary is equal to 50,000. Medium. No. Low. Example 3. Bonus calculation. Every employee gets high 20%, medium 10%, low 5%. Select. Employee underscore name. Salary. Case. When salary is equal to 70,000 then salary asterisk 0.20. When salary is equal to 50,000 then salary asterisk 0.10. Else salary asterisk 0.05. And bonus. From employees. Output. Name. Bonus. Ali.
2,000.
Sara.
6,500.
John.
18,000.
Underline logic. Check salary. Choose bonus percent. Multiply. Example 4. Customer status. Table. Customer. Orders. Ali.
15.
Sara.
8.
John.
2.
Query. Select. Customer underscore name. Orders. Case. When orders is equal to 10 then gold. When orders is equal to 5 then silver. Else bronze. And membership. From customers. Output. Customer. Membership. Ali. Gold. Sara. Silver. John. Bronze. Underline logic. Orders.
10.
Gold.
5.
Silver. Bronze. Example 5. FAANG interview question. Find whether each customer is high value, medium value, low value. Select customer underscore name, sum, amount, total sales. Case: when sum, amount, is equal to 10,000, then high value. When sum, amount, is equal to 5,000, then medium value. Else low value. And customer type. From orders. Group by customer underscore name. Output. Customer. Sales. Type. Ali.
12,000.
High value. Sarah.
6,500.
Medium value. John.
2,000.
Low value. Underline logic. Calculate sales. Compare. Assign label. Why case is powerful. Without case. Salary.
70,000.
With case. Salary.
70,000.
Senior employee. You convert numbers into meaningful business information. Real-world uses. Customer segmentation. Salary bands. Product categories. Employee grading. Exam results. Credit risk levels. Sales performance. Fraud detection flags. Shipping priority. KPI dashboards. Common mistakes. Mistake 1. Wrong order. Case: when salary is equal to 50,000, then medium. When salary is equal to 70,000, then high. And everyone above 70,000 also satisfies salary is equal to 50,000, so they'll never reach the second condition. Correct. Case: when salary is equal to 70,000, then high. When salary is equal to 50,000, then medium. Else low. And mistake 2. Forgetting else. Case: when salary 50,000, then high. And rows that don't match will return null. Mistake 3. Missing end. Every case must finish with end. FAANG interview questions. Q1. What is case? Answer: conditional logic inside SQL. Q2. Case is similar to which programming statement? Answer: if, else. Q3. Can case return numbers? Yes. Q4. Can case return text? Yes. Q5. Can case be used inside sum? Yes. Example. Select sum. Case: when department is equal to IT, then salary. Else 0. And as it underscore salary. From employees. This technique is called conditional aggregation and is very common in dashboards and interview questions. Mini project. Company wants a dashboard showing employee levels. Rules. Salary greater than or equal to 80,000 rupees executive. 60,000 rupees to 79,999 rupees senior. 40,000 rupees to 59,999 rupees mid. Below 40,000 rupees junior. Write a case expression that assigns these labels. Practice exercises. Label students as pass-fail. Categorize products as cheap, moderate, or expensive based on price. Assign shipping priority based on order amount. Classify customers into gold, silver, or bronze based on total purchases. Calculate bonuses using different percentages for different salary ranges. One-page revision sheet. Keyword. Purpose. Case. Start conditional logic. When. Check a condition. Then. Return a value if true. Else. Return a default value. End. Close the case expression. Memory trick. Case is equal to if else. Case. When. Then. Else. End. 80/20th rule. Master these 5 patterns. Simple if-else. Multiple conditions. Labels, gold, silver, bronze. Calculations, bonus, discount. Conditional aggregation with sum, case when. These patterns cover a large percentage of real-world case usage in analytics and many interview scenarios.